Well, welcome everybody, and welcome back to the CIB Presidential Seminar Series that we broadcast from Purdue University. As I have mentioned in the previous seminars, that this semester we are bringing in panelists on various topics every week to set the stage for discussions for the World Building Congress, which would be held at Purdue University from May 19th to the 23rd. The theme of the World Building Congress is what role the construction industry can play in supporting the UN Sustainable Development Goals. So with that said, the panel topics are designed to start that discussion, to bring everybody's thoughts forward. And in that series, today we have put together an excellent panel with four distinguished speakers. We have Professor Mohammed Dulaimi, Professor Jeremy Gibbard, Professor Jacob Beets, and Professor Shen Wei. So let me give a quick introduction to their achievements, and then I'll hand it over to our first speaker. That's going to be Professor Jeremy Gibbard. So Professor Gibbard is from CSIR in South Africa. That's the Council for Scientific and Industrial Research. He's also the commission lead for W116 or CIB W116, which is for smart and sustainable built environments. His work explores how smarter, more sustainable, and inclusive built environments can be developed. He has carried out a wide range of policy research, training, guideline developments, and building environment projects for multiple agencies, including UNEP, ILO, UNICEF, UN Habitat, GEF, EU, the World Bank, the Royal Academy of Engineering, and many others. He coordinates, as I mentioned earlier, the CIB Working Group 116, which is on smart and sustainable built environments, and is a board member of the Globe Consensus. He's on the editorial boards of the Smart and Sustainable Built Environment, Building Research and Information, and ACTA Structila journals. Dr. Gibbard, as I mentioned, is a professor at University of Witwatersrand, and he's a chief researcher at the CSIR and principal at Gage. Our next speaker, Dr. Jacob Beets, is a university professor at RWTH at Aachen University in Germany. And I apologize, the flyer said New Zealand, but we got him back in Germany. He's the coordinator for W78, which is the Information Technology for Construction. He graduated as a diploma engineer from Bauhaus University in Weimar in 2003 at the chair of Informatic in the Architecture under the supervision of Professor Dr. Engineer Dirk Donath. He was awarded a PhD degree for his work on facilitating distributed collaboration in the AEC FM sector using semantic web technologies, supervised by Professor Dr. Engineer Bauke de Veres, I hope I pronounced that right, and Dr. Engineer Joswan Leuven at the ISB group of the Department for the Built Environment at the TU Eindhoven. He's author of more than 80 scientific peer-reviewed publications and co-editor and author of the books Building Information Modeling, Technology Foundation and Industry Practice, Building Information Modeling, also in German, so both English and German. He co-founded the open source collaboration platform bimserver.org and laid the foundations to the OWL representation of the Industry Foundation class IFC, referred to as IFC-OWL. He has participated in numerous research projects, including EU FP7, DURARC, EU H2020, and so on, and is active in committees for the standardization of interoperability in information exchange for building industry on national, EU, and international levels. Our third speaker is Professor Dr. Shen Wei. He's from University College London. and he's the coordinator of W98, which is Intelligent and Responsive Buildings. Dr. Shenway is an associate professor in building services engineering at the Bartlett School of Sustainable Construction at UCL in UK. Dr. Way's main research direction includes occupant behavior and thermal comfort, building energy storage using PCMs, and the optimization of district heating and cooling systems. Dr. Way has authored and co-authored over 130 journal articles in key academic journals like Energy and Buildings and Building and Environment. Dr. Way is currently the coordinator of CIB W98, which is Intelligent and Responsive Buildings, as I mentioned earlier. He's a fellow of ASHRAE, a key member of CIB SE, Intelligent Buildings Group, the associate editor of the Journal of Intelligent Building International, and the chair of the Student Activity Group in ASHRAE in the UK. Our fourth speaker is Professor Dr. Mohammed Dulemi. He comes from Leeds Beckett University in UK, and he is leading the Task Group 96, which is on accelerating innovation in construction. Professor Dulemi is the head of engineering and the professor of construction project management and innovation at the School of Built Environment, Engineering and Computing at Leeds Beckett University. He's the leader of Accelerating Innovation in Construction Research Group and the joint coordinator of CIB Task Group on Accelerating Innovation in Construction, as I mentioned earlier. Professor Dulemi has a strong international profile through working for more than 30 years in universities in the UK, Singapore, and UAE, delivering high-quality teaching and research in construction management and project management. He has a strong publication record in premier journals, international conferences, and the professional press. Professor Dulemi has led a number of research teams to deliver high-quality research. He has worked closely with industry and government departments to address the major challenge of developing and delivering innovative solutions. In addition to CIB, Professor Dulemi is a member of CIOB and a chartered construction manager. So with that quick, brief introduction, please welcome our four speakers. And let me hand it over to Professor Jeremy Gibbard. Jeremy, over to you.
All right. Thank you very much, Mark. Can I just double check that you can see my screen?
Yeah.
Yes, we can.
Great. Okay. Thank you very much for the invitation. And what I'm going to cover is probably quite a lot broader than perhaps some of the other speakers. And I thought it's quite important, perhaps as the first one on, to give quite a big picture. We're talking about the SDGs, Sustainable Development Goals, that countries have signed up to. We've got a target for 2030, and are we going to achieve them? So that's the big picture. And what we need to do, really, as built environment researchers, is make sure that the built environment, construction, contributes to achieving those goals. So when I looked at the presentation, I'm going to really look at a kind of broader view. I'm going to say, first of all, if we're looking at ICT, if we're looking at technology, why are we not successful? Why are we not making sufficient progress? So the very first question is an important research question. We're already 2024, 2025, and why are we not making good progress? So that's the first question. The second question is very much around progress and transformation. If we've got to make a very radical shift in the way we're organized, in our technology, in the way we plan cities, we manage cities, what is going to do that? So again, very clear questions there. And then the last one is, we've found the right technology, we found the right organization. How do we drive that progress? How do we get it implemented in governments, in the private sector, in society in general? And really, how can you use ICT for that? So I'm then going to end with a question, which is, what should we be exploring? And we'll get back to that in a little bit. So what I'm going to do is I'm going to draw on some of the projects that I've been involved in, so that I can kind of illustrate really what I mean by some of these ideas. And to start off with, we need to look at progress. So this is um, a plan that shows globally how we're doing in terms of SDG 11, sustainable cities and communities. And if we look at this, and we look at Asia, Europe, North America, largely they're all categorized as challenges remain or significant challenges remain. If we look at Africa, South America, parts of Asia, there are a lot of countries that have major challenges. And there's no specific country that actually is doing well, is going to achieve the Sustainable Development Goals. And so one of the things that ICT has enabled us to do is to track data very well, and enabled us at any point in time to be able to see where we are in terms of different sustainable development targets. So that's working, it's very effective, and this is what you can use as a citizen, as a president, someone within a particular sector. But what it shows is it shows we're making very poor progress. And we then need to go back to some of the kind of fundamentals. Why aren't we making good progress? And why are some areas, particularly look at African countries, making less progress than others? And it comes back down to some very key elements. It comes back down to awareness, advocacy, identifying the key leverage points, the key role players, and then showing them the impacts of not doing things, showing the benefits of change and following particular technologies and organizations that will make sure that you achieve the SDGs. And once you've got momentum around it, you can then build the policies, you can then build legislation, you can then build change within the private sector and civil society. So this particular project is a kit that we developed for One Planet Network that really enables a country wishing to look at sustainable building and construction to build that momentum. And so really what this does is it says, how do you build momentum behind change and make sure it happens? And very important here is the social and organizational aspects. And often as built environment researchers, we tend to focus on technology. And we also need to think about the technology around behavior, around organizational change, around building momentum behind a movement. And so this is quite an interesting aspect to look at. Key to that is awareness. And technology is extremely good at this. We have apps that you can download that can give you instant feedback in terms of your carbon emissions, in terms of your consumption of resources. We can put in sensors in our cities, and that can give us, again, real-time data on things like air quality, on health impacts, of traffic jams, congestion, etc. So we have fantastic technology that we can use to drive awareness, to drive advocacy campaigns. And we show this very well in one of our SASB seminars that we ran a couple of months back on citizen science in Kampala, in Nigeria, Uganda, Kenya, etc. And what it showed is that you can build quite quickly with simple technologies a movement then starts to change how public transport works, how cities are designed. So very important to use this technology to drive change and to take citizens with you. We also have fantastic technology now that can take readily available data. So if we're interested in something like 15-minute cities and accessibility to key aspects, so children walking to school, people going to work, food shopping, etc., we can get that data now pretty readily, and using software like this, which is online, we can map cities, we can map neighborhoods, we can map particular urban areas, and look at the quality of that urban fabric in terms of accessibility. So very quickly, we can start reorganizing that urban fabric. We can look at how we can change that, make sure it's accessible, bring in other services so that we improve the ability to reduce transport impacts and enable improvements in quality of life by much better designed and managed urban fabric. One of the projects we've been working on is a project where we looked at modeling circular economic impacts options for a large city of Joburg, which is very close to us. So we took a lot of the existing data and we modeled different scenarios. So this particular example shows modeling development over the next 15, 20 years around 50-minute principles. And what that showed was that you could fairly easily enable 100,000 additional people to be able to walk to work, children walk to school, etc. Another example of that is that if the city adopted a process of ensuring that there was much more deconstruction and reuse of building materials instead of demolition, you could reduce waste from end-of-life buildings by 44%. So again, huge impacts in terms of reductions to landfill in terms of transport and waste, etc. Some other examples. So this particular modeling, we looked at rainwater harvesting, again, for the city of Joburg. Very unreliable water supply. It's piped, a very long way, and there's always water shortages. And if you include rainwater harvesting as a requirement and build that into your buildings, you can reduce water demand by 25%. So again, very useful information for city planners planning the city over time. The same thing with something like local composting. Instead of all of your organic waste being taken to landfill, you could avoid a lot of that by having local composting. It could be used in urban agriculture, and you can create a lot of jobs, local jobs, very important in developing countries. The very last one is the idea of integrating urban agriculture into cities. So you can map all the available land and you can find suitable land for urban agriculture. And what this shows is that, again, over time, you could enable about 20% of your vegetable requirements for a large city to be sourced from local urban agriculture. So again, very important, particularly in developing countries, in terms of health, in terms of food security, but also in terms of things like embodied energy, carbon emissions associated with transport. So ICT simulation modeling, extremely useful for these sorts of exercises to enable good decision making based on data, based on evidence. The next project I'm going to talk about really starts shifting into how cities work. What are the planning processes? What are the management processes? And a lot of cities follow exactly the same processes. There's a strategy, there are integrated development plans, there's spatial development frameworks, and the ideas filter through into neighborhood plans, into transport systems, etc. But what they don't do is tie back to the evidence, tie back to the science. And so what this particular project did was develop a mechanism of making sure that we piloted very effective, promising technologies or organizational change, and that built that in to the way the city planned its neighborhoods. So where it was successful, it then integrated that as a very effective way of planning new neighborhoods or changing neighborhoods. And so it's a very important part in terms of embedding change and making sure it happens. So it's not enough to have the idea. It's not enough to develop the technology. You've got to embed it in your city planning in your management. So to come back to my original question, very important, I think, for built environment researchers really to kind of understand why we're not more effective, why the change is not happening enough. And we need to really think through things like advocacy, impacts, incentives, behavior. Sufficiency, the whole area of sufficiency shows that you adverse behavior, erratic behavior can reduce a lot of the impact of a technology. So we need to understand those dynamics, very important. The second one is what we generally tend to focus on is what is the technology? What are the organizational aspects? How do we drive change? Things like 15-minute cities, circular economy, sufficiency, increasingly AI, fantastic tools for optimizing for a particular set of parameters. So optimizing urban fabric for sustainability, optimizing city management for sustainability. And then the last thing really is to kind of come back to this is that we've got to embed this into the way cities work and develop and evolve over time. And I know a lot of built environments will say that's not our job. We'll develop the technology, you do it. But one of the reasons why we're not being successful is that all the built environment research and effort goes into two. And there are big gaps in 1 and 3. And my argument really in this presentation is that we need more people to get into those areas and to drive that change far more effectively, really across the whole value chain. Thank you very much. Those are some of the references, and look forward to some questions at the end. I also generally do a blog where I can put some of these references in. So thank you, Mark.
Yeah, thank you very much, Jeremy. That was a very interesting opening, setting the stage for, what we understand by the SDGs and how they could be implemented in the built environment. So let's carry that discussion forward to Professor Beetz to bring it in perspective from the IT point of view. One of the interesting things that as Jacob is loading his slide was, our prior discussion about how cell phone technology has allowed to propagate, throughout, whether that's a developed country or developing country, irrespective of that, the technology has been helpful for everybody in all parts of the world. So a bigger question would be, can that technology somehow be useful for us in promoting SDGs and the use of IT? So Jacob, please take over.
Yes, can you see the slides and can you hear me? Yes.
Yes.
Thank you very much for having me on. I've kind of focused on, I brought to you one of the aspects of IT for the smart and sustainable built environment pertaining to caring better about all the things that we have already built. And I'm doing this along a selection of projects, starting from the left, from a PhD project pertaining, and a National Research Foundation project pertaining to the extension of the lifetime of bridges, to two projects from war-torn zones in Ukraine, and how low-cost IT and low-cost IT can help rebuild war-torn areas, and then a bachelor project. So it focused on again very cheap technology on your mobile phone to prevent the deterioration of cities in tropical zones deteriorating from the harsh weather conditions. Thank you very much for introducing me. So I just a few words. We're a pretty big university in Germany. I'm at the Department of Architecture, and we're a small shop compared to some of the other chairs within this university that has been around for for 150 years already. I'm doing building information modeling for the most part, and I'm very interested in the notion of integrating different data sources in order to get a better picture, and then in order to make better decisions for engineers to, yes, and what I brought to you today is some of the IT application domains for the existing building stock. It's probably a pretty European topic, but that's what I really think where we have such a large potential to bring IT to the table for the in order to reach the SDGs. The right-hand side picture, I took myself on the morning of the crash of a bridge in Dresden in the UK. To the left is a deteriorated road in front of my supermarket just around the corner. And to the very left is the overflowing Rhine that overflows the Rhine River that runs through the city that I live in. So it's a German. So these are all handmade on a cellular phone, taken within the last couple of weeks, and they go to show as an example of what it is that I think should have more attention, or that I pay a lot of attention. So if you look at the IPCC reports over time and again, the built environment has been identified as really having a really large potential to preserve some energy, preserve some CO2 emissions, and so forth. However, the other fact is that we have by now, a couple of years ago, we kind of tipped the balance towards having built more stuff in the built environment than if you put this on one side of the scale, and on the other side you put all living organisms, including trees on the other side, then we have tipped the scale. So we have to kind of prevent and stop doing the video on the right-hand side, and we have to take better care of what we have already, excavated from the crust of the earth, and with a use of lots and lots of energy. So we have to take better care of that. So that's kind of the topic of the four presentations, or of the four example projects that I brought for you, demonstrating some of the potential of IT that we said. On the other hand, so in the face of these enormous challenges, we have the fact that the construction industry is at the very bottom of all indicators with respect to digitalization. So this is still today how we operate: paper-based, very intransparent, not very focused around digital media. So this is the challenge that we face now. Onwards to a number of small projects. This is an ongoing project from the National German Research Foundation for the preservation of bridges, where we have all sorts of data. So as most of the bridges in Germany, most of the 50,000 bridges in Germany have been erected after the war. And after almost 80 years, many of them, come into a critical condition. They are inspected every 3 years with a small one, and every 6 years with a big inspection. And then the engineers go around and take annotations, and they take pictures of damages. They mark up things in handwritten notes and in pertaining to the damages that they find. And then we have all of this legacy, pre-digital age legacy data of what the bridges are. This particular one is a little older bridge. So every 3 years, a new engineer comes to the site and says, okay, there's a crack on the upper left-hand side of the third field in the third girder. What do we do? Has this been there before? Has this grown? Has it become severe? So integrating this kind of information really requires you to kind of get the data out of the silos and to integrate them in order to enable a machine, what an engineer that has been trained on site and has been doing this for years and years is able to do in her head. So over kind of superimposing all the different information types in their heads is something that we humans are very good at. But if we don't have the means of IT infrastructure to do that, then we're losing a lot of insight, and we're losing the ability to kind of see things at the same time. So trying to get knowledge modeling, particularly pertaining to spatial types of knowledge. So if I know, if all of you can see that this is obviously a section, and this is obviously a 3D model, then we can kind of do the acrobatics as trained engineers to put this together. But what do we have to tell the machine to do that? And for this, we are building knowledge models, and we're using machine learning approaches to kind of train a system to be able to locate all of these different types of media into a virtual space in order to understand what's going on. We have been doing this with a lot of fellow engineers from the bridge design departments around Germany for existing bridges, and we accumulated lots and lots of data. And we're now semi-automatically, with a success rate of roughly 80%, we're able to kind of locate all of these legacy information types into superimpose this into a virtual space. So this is some of the things that I think is very interesting for the preservation of information. Another one is if we now, this is a master's thesis from last year of a student that comes from Ukraine, and as you might know, that there's quite a lot of post or Soviet area prefabricated buildings, and instead of tearing them down, she looked at intelligent ways to identify the blocks that can be preserved, and to bring in wooden panel construction to enable buildings to be used again, while without demolishing them, but really sufficiency was already named as one of those concepts to just do what's the bare necessities to make them inhabitable again, and doing this with automation and at a speed that human engineers would be overwhelmed by. So one of those examples, preserving the built environment. Other examples where we have to kind of look into how can we rebuild with minimal means destroyed areas. This is in the outskirts of Kiev, of the capital of Ukraine. This is how far the Russian tanks came. This is where the student actually lived. And so she made kind of a digital tool, a parametric tool, to enable the quick rebuild of this once, the conditions allow this, by creating a rapid decision-making tool that is much faster at creating new layouts on an urban scale, with very few parametric changes. So this is some of those opportunities that I see in the preservation. This is a very recent. This has been handed in last week, and this is in collaboration with a guest professor from Cuba, Havana, where they're really fighting a quickly deteriorating building stock, brownfield building stock, mainly due to the absence of means to replace doors and windows. So the rainwater comes in, and then from then on it's downhill for the buildings. So with a very lightweight technological means, everything is affordable by the people there, scanning your door for damages, having on a Raspberry Pi, on a very low end technical device, having the scan replaced with infills, and then generating this infill with material you have, again, just with a minimal amount of material available, and all in open source, in well, readily available low tech means that can be afforded by, for example, the citizens in Havana, Cuba. This is just a small, a random selection, semi-random selection of some of the application domains that I see for IT and construction geared towards reaching sustainability goals. Thanks a lot for the invitation again and for the attention.
Thank you, Prosbeats. That was putting a good perspective on application of IT in construction. Thanks for sharing those projects. Let's carry that conversation further to Professor Shen Wei.
Okay, thanks a lot. So let me share my screen. Yeah, can you read it now?
Yes, we can. Yeah.
Okay, so firstly, I would like to say thanks a lot for the invitation. So really be my honor to be able to present some of my knowledge to students in the US. And actually, so I will talk these topics from, or analyze this topic from the building performance from at the operational stage. So these are the contents that we included. So of course, I will just start from a very brief self-introduction, and then I will say something about building performance and the building services. Maybe you have heard this term in the USA, or maybe you use another term. So we can discuss it later on. And then I will say how IT innovations promote building performance at the operational stage, and then I will use one slide to talk about our CIB W098, so what we are doing. So I did my undergraduate in China, so in the building environment and facility engineering. So the old name of this program is the HVAC, so heating, ventilation, air conditioning. So it's just a new name for this term. And then I did my master in Denmark in mechatronics engineering. I did my PhD in building service engineering at Loughborough University. Got some working experience at Plymouth University, Loughborough, Northumbria, and now I'm associate professor in building services engineering at UCL in the UK. So I have some main research directions, like what has been introduced at the beginning. So one of the most important ones is occupant behavior and thermal comfort. So this starts from my PhD at Loughborough University. And then also the fixed changing material, how to use this energy storage technique. So to save energy for buildings is another research interest. Okay, so I think our earlier speakers have already said something about the importance of building energy consumption, right? So we all know that, so buildings account for almost, I think, 40% of the society building the energy consumption. And basically, so this part of, this leads to a very huge contribution of the CO2 or the carbon emissions. So in the building sectors, normally, so this carbon emissions consist of two parts. One is the energy from the building operation. So when we use the building, we need to heat the building, we need to cool the building, and so on. And then the second one is what we call the embodied carbon, so which are the materials used to construct the buildings. So the carbon emissions engaged in the production of the materials, transportation of the materials, and also the final construction of the building. So of course, it's very important if we want to achieve the sustainable development, we need to reduce the energy consumption of the building. This is also one the main topic where I think in my area, so the ICT can help us to achieve. So from this picture, you can see that, so this just justifies, so this is the USA data. So you can see that the building sector currently, they contribute to a very huge proportion of CO2 emissions. And also from the projection, we can see that, so in the next couple of years until the 2050, so we won't see a very good improvement or reduction. So this, this is why, as a researcher in the construction industry, so we need to think about that, how we can make this reduction faster. And also, I attended a speech from one of the renowned professor in the UK. So actually, he said that even that now we make all of the buildings zero carbon, so still the climate change will be worse in the next couple of years, or at least in the next 5 to 10 years, because the emission or the pollution is there already. So we need to be aware of this as well. So about building operation, okay, so the most important thing we need a building is to use is thermal environment or environmental environment. So that's why we need to talk about the environmental performance first. So basically, so when we are talking about when we are designing a building, so about the indoor comfort, there are 4 main aspects. The thermal, right, heat or cool. So the thermal environment, which is achieved by heating, cooling, or our air conditioning system, they are also a very huge energy consumer in our buildings. And then indoor air quality, so mainly provided by the ventilation system. We have the visual environment, so provided by the artificial lighting and daylighting. And then we have the acoustic part, which is mainly achieved by soundproofing and the noise attenuation. Of course, when we build up a building, thermal environment or environment is not only the only thing. We also need a building to provide us with some other services. So for example, the water supply, the drainage, so transportation, so fire and safety, and communication and security. So all of the things. So we need to make sure that they are considered efficiently in our building design and selection. Then what are they? Okay, so at least in the UK, I'm not sure how do they code in the USA, but in the UK, they were all considered into one system, which is called the Building Services Engineering System. So from here, so you can see this is called CIBSE. Okay, so at the beginning, our chair just called CIBSE because we all know ASHRAE in the UK, right? So it's the American Society of Heating, Refrigerating, and Air Conditioning Engineers. So in CIBSE, in the UK, we have an equivalent institution which is called CIBSE. So the Chartered Institution of Building Service Engineers. So they are working very similarly as what ASHRAE is working in the USA. So for CIBSE, so they define building service engineering as all about making buildings to meet the needs of the people who live and work in them. So you can see from here, they have covered a variety of different functions supplied in a building. Then let's talk about ICT. So where ICT is mainly used. So so you can see that the systems in the building is very complex. So it considers different aspects, different areas. So in order to achieve an efficient control of those systems, so the people or the buildings, now modern buildings, will install this thing called the Building Energy Management System, BEMS, or Building Management System, BMS. So this system is purely based on data communication and manipulation. So you can see here at the bottom side, we are using a number of sensors, different types, to monitor different environmental parameter or non-environmental parameter, and then these parameters will be sent to a controller. So the controller will make some computational calculation based on, for example, PID, PI control, or some other control methods. And then this control will decide what is the best option for the plant, the field plant, to work, whether we want to provide more ventilation or we want to reduce the flow rate in the system. So then the signal will be sent to the actuators to make the action happen. And of course, people want to monitor the whole process to make sure that they are working appropriately. So that's why we also can use the monitor software to see the operation of the systems. So according to my knowledge, I just summarized the 4 main research directions or maybe development directions. They are not only for academia, but also for industry. So where we can better use ICT to promote the energy performance of buildings. So the first direction is to use advanced sensor technologies for collecting wider and more accurate data. For example, now a lot of buildings, they use the PIR sensor, right? The passive infrared sensors to detect the occupancy of the room. But we also know that PIR sensor can only tell us whether the room is occupied or not, but cannot tell us how many people is using the room, and also cannot tell us who is using the room. Okay, so advanced or more advanced technologies in the future may tell us who is using the room and how many to give us a more accurate decision making for what setting do we need for the system. So this is the first one. And the second one is the machine learning or the artificial intelligence. So we all know in this year, the last year, the AI development has been much faster than what we are expecting. So how we can better combine those algorithms into our fault detection or our efficient system operation can also be a very, very useful research direction or development direction in the future. So the third one is the friendly user interface. So I just had a talk with one of the biggest company in the UK, which is called Weights. So also in the meeting, we mentioned that so even for us, we are building service engineers, but a lot of operational system, the user interface it's not designed user friendly. So even for us, I have to use a lot of time to figure out how they are working. How should I turn the different values inside? So that is why, and then following that, so we will also want to make energy efficient users. We always telling about, okay, so low energy buildings or low carbon buildings. So all of this concentrate on the technology side. How about the users? Right? So at the beginning, so our first speaker also said, this all links to the social system, the institutional system. Okay, so how we can engage the users better? Okay, so we provide feedback system for the users to tell them what you should do now. But how to provide this system, how to make decision making will also need support from the ICT technologies. So after we have all of this, we come to the very hot topic recently, which is called the intelligent or smart buildings. So you can see that intelligent building management consists of a variety of aspects in the building, not only about the technology side, not only about the HVAC side, but also includes the human side, the social system, and some feedback system, and so on. Okay, so in order to get this, a very complex system should be built up, and then to make sure that the information shared within this whole system or the whole framework are secured and efficiently. So the last slide, I would like to just to say something about our commission. So we are called Intelligent and Responsive Buildings. So I'm now working together with Professor Derek Room, so at the University of Reading in this permission. So we are not only considering technology side, but we want to make our commission more like a multidisciplinary environment. So we also welcome people from architecture, or people from social science, and so on. So who wants to contribute to the intelligent and responsive building control and system. And also, because we are mainly based in the UK, so we are also working closely with the CIPC Intelligent Buildings Group, the ASHRAE UK chapter, and also we have this journal which is called Intelligent Buildings International. And of course, you are all welcome in the future. If you have any papers you want to publish, and please submit to our journal. Okay, so that's the end of my presentation. I don't give any example, but I want to just give you some very fundamental idea about this area. Thanks.
Thank you, Professor Wei. Thank you for bringing in the perspective of intelligent and responsive buildings and tying it very nicely with the IT and sustainable impact that we were trying to explore. So let me move on to our last panelist today, Professor Mohammed Dulaimi.
Thank you very much. Can you see my screen?
Yeah.
Wonderful. Let me just... Well, thank you very much for attending. The agenda for innovation has been with us for a very long time. And the issues of change, the importance of the industry, that the industry needs to change, has been with us for quite a long time. And sometimes, personally, I feel disappointed that when you listen to reports coming out talking about the construction industry, the poor quality of the product or the service, and how our users, our clients, are not happy with certain aspects of our service. I ask myself, it's been 40 years now. Almost everyone working in the industry would have come through an education system that has emphasized those issues, the issue of quality, management of risk, integrity, and ethical behavior. So I think the agenda of innovation has moved on, and that's why we set up Task Group 96. It's no longer about realizing innovation, but we need to accelerate the pace of innovation. The current pace is not satisfactory. The reason the scene is different today is that for a very long time, the construction industry have argued that it's different, and therefore what's happening somewhere else in other sectors of the economy is not necessarily applicable to construction. However, the pace of innovation in every other sector has created significant pressure on construction, because the digital revolution is affecting every aspect of our lives. And we spent almost all our lives, unfortunately, indoors and in the built environment. We're no longer happy for our internet provider to come and drill a hole in the wall so we can get internet service, or extend a cable so that we have TV in one of. That's no longer acceptable to our clients. And also, I was listening with very exciting presentation from my colleagues. Jeremy talked about how digital tools providing us with data that provide evidence of how change could impact the built environment, impact sustainability, and therefore can support decision making. Also, Shinwei, when he was talking about the control systems and how the importance of the control systems to help us understand how our services work, and therefore we turn our users to smart users, and therefore they understand how changing behavior could help them make an impact on their lifestyle, as well as an issue of sustainability. What's different now, the scene now, as far as the construction industry is concerned, is that the innovations they're using, and I'm trespassing on Shinwei specialism. The controls that we're using in our built environment are manufactured outside construction. I was talking to my colleagues in building services, and they were talking about control units. And when I was asking them some questions, they said, "Mohammed, this is electrical engineering, electronic, that they're the one who developed the board." And I said, well, in this case, we cannot isolate, in this environment, we cannot isolate the construction industry. By opening the door and entertaining products and innovative products and services from other sectors, we're increasing the complexity of our organization and put greater pressure on management of construction, of how to manage this complexity. And we're going to see, and this is what I think is likely to happen very soon, is we start seeing new entrants to the industry that in which they become bigger player in the construction process. Questions have been asked 30 years ago. Why a building that predominantly, in terms at least of value, is focused on building services, has to be led by a constructor, okay, by a builder, shouldn't be led by a building service engineer. And this quote that I had from the 1990s, if you bring it today, start raising question. If we're developing a smart, sophisticated, digitally operated building, why a constructor should be leading that particular project? Shouldn't be the one who develops those smart systems. So I think we are approaching a stage where we're going to see new entrants, different kind of entrants to our industry. And there are greater expectations that innovation is going to help us achieve significant improvement. It's the expectation that we're going to adopt innovation. I have an example which I think students will recognize. Once I was in a classroom and I was talking to students, talking about assignments and what have you. And one of the students, and I mentioned that they need to write an executive summary. And one of the students raised his hand and he said, Mohammed, what is an executive summary? And I said, why not ask the device you've been fiddling with? You know, through lecture, you're typing and using your smartphone. Why you're not? And he smiled. And I was making a point. I was not trying to make him to embarrass him, but it was the expectation that he's not going to use the smart device in asking a question because that's the practice. The practice is to ask the teacher rather than deploy the digital device. That the description of Shenwei, where there's an interaction between the technology, between the users, and getting the user to become smarter and understand how they behave. That kind of interaction we need to understand because it's very powerful. One of the reasons the industry hasn't changed is because they don't see a justification for such an investment. Asking them to step out of traditional practices, there should be a reason. Businesses are there to make a profit. They want to remain viable. And therefore, to ask them to invest into new practice, they're not going to do that if it's not commercially justified. Clients are at the heart of our projects, and they are the one who set the agenda. If they are not following up on the sustainability goals, then there is very little motivation. There is no incentive for the supply chain to focus on that. Talking to industry, we're still talking about cost. We're still talking about reducing cost. And project managers, if you talk to them, and you'll tell you that when they start the project, they're talking big about sustainability. But by the end of the project, they see what they have delivered is so small. Why? Because the decision-making process was not driven by sustainability. The KPIs they're using, the measurements they're using, they were all focused on costs. Now, one of the things that we need also to realize with the adoption of digital tools, the pace of work is going to increase significantly. And therefore, the space for us to think and consider and make decisions is going to be to shrink. And that's a challenge that always occupy my thinking, is that we are used to be asked a question and then we think about it. It takes us a week until when we have to deploy the solution. Now, actually, it's not a week. It could be a day or could be less than a day. And therefore, we need to start thinking about new different tools for thinking and how we can solve problems very quickly. The contractual implications of any change is significant. Who's taking responsibility for what? Remember when I mentioned that in construction, what drives businesses is profit, or at least remains commercially viable. We're still talking about prefabrication. In UK, they refer to it as modern methods of construction. And I smile because when I was doing my civil engineering degree years ago at University of Baghdad, we had a guest speaker from industry, and he shared with us how they are using prefabricated units. So the technology, and I can see one of the questions of the audience, the technology and the ideas are there. It's the decision to adopt them that is challenging. And the adoption of that is related, it impacts the roles within the industry. I want you to imagine a contractor with $1 million building, and they will get a margin on the 1 million. Okay, let's say 10%, 5%, whatever it is. If they adopt a different technology, if they adopt a different approach, let's say using prefabricated units, that element of the building is no longer within their own control. It goes to a service provider, a manufacturer. And therefore, instead of getting 10% on 1 million, they get 10% on 800,000 or 700,000, okay? So the motivation, we need to start thinking about the motivation, how we affect the motivation. And again, the driver here has to be the client. And the biggest client is government. And I work with public clients, and again, they have an agenda set by the government, and they're driving this agenda. What I'm doing, the research that we're doing now, is how the interaction and engagement of public clients with the supply chain can provide them with that influence. Because in every construction industry around the world, 95% are small companies. We call them SMEs, small medium enterprises in the UK. Those SMEs, they do the majority of the work. They don't listen to you as a client. They listen to the contractor, because it's the contractor who employs them and the contractor who pays them. And if you, we had 2 meetings, one with the main contractor and one with the subcontractor, and you can see the difference that the SMEs, the small contractors, they have a lot of potential. They have a lot of possibilities. They have innovation, but they only work to the agenda of the main contractor. When you mention the client, and our client is very proactive, still I felt the influence is not significant. And we need to know how, through the interaction and deploying digital tools to facilitate that interaction, we're working now to see how we can develop those digital interactions so that the client remains a powerful source of have influence in driving the agenda of the project. So we start creating these smart alliances. I have a vision that subcontractors, small contractors, we start looking at them as startups. Big companies today in every sector of the economy, when they have a problem, a challenging, complex problem, they find it challenging to deal with them within their huge organization. They identify small startups who set up for the main purpose of delivering that innovation. Of course, how in education, I'm conscious of the time. So We need to speed up the search for solutions. We need to ensure that we enhance the absorptive capacity of organizations, of teams, enable them to benefit from the development of technology and the diffusion of innovation, which is a major challenge within construction. I just wanted to, before my last slide, I like this one, a bit out of date maybe, but you can see from that how companies are venturing outside their own, they recognize the skills they have, the ideas they have, and they can see how they can be applied in a different environment. And for your students, I would strongly recommend that you start thinking, if you have an innovation, a new idea, think outside the current setup and ask yourself, where can this idea makes the biggest impact? As you can see, BMW, Mercedes, they're all working outside their own sector and finding a use and application for their own knowledge and skills. And I'll stop here.
Thank you, Professor Dulemi, for bringing in that perspective. Very interesting. So we heard 4 different perspectives, starting with smart and sustainable built environment, the information technology for construction. Then Professor Ray talked about intelligent and responsive buildings. And finally, how can we accelerate innovation in the construction industry? So let me open the floor we have about 19 or 20 minutes left for Q&A. So let me open the floor for questions. Ala, I think you have a question. So why don't we start with you?
Hello.
Ala, you there? Yeah, go ahead, please.
So my question was, do you think sustainability in the future will be one of the main reasons for the SDG development goals? Like,
Who would you like to address? Go ahead, Jeremy.
I think just conceptually, sometimes it's useful to go back to definitions. So historically, we've had a very strong emphasis, particularly in developing countries, on climate change, on carbon emissions. And sustainable development and the sustainable development goals are very different. So they talk basically about targets and indicators of a very different type of society, of a very different type of organizing our cities, our buildings, our construction sectors. So if you look at them, they're targets for education, for health, they are target for water, etc. And the interesting thing that I found looking at them is that quite a lot of the SDGs won't be met even by the most advanced societies, Sweden, Denmark, wherever it is, won't meet some of the kind of basic SDGs. So what's important is to kind of have this conceptual framework, is that there are targets for 2030, and, you know, countries have signed up for them, and they need to filter through into the respective sectors, including built environments and construction. So, you know, if we're looking at energy, if we're looking at health, they need to come through in policy in built environments and policy in construction. And what is important here is that I think we need to distinguish between the process of getting to a much more sustainable society, so a state where we live within the global planetary boundaries. There is we aren't breaching any of the kind of major environmental aspects, and there's a reasonable quality of life. People are healthy, people have work, people are well educated, etc. So that's the state of sustainability that we need to aim for. And really the process of getting there is sustainable development. And the SDGs is a way of tracking that process. And the way we get there is going to be very, very different depending on where you are. So developing countries need to address unemployment. They need to address health. They need to address education. Whereas very high consumption societies, you know, the US, Sweden, Denmark, the UK, has to address their environmental footprints, all the damage that's been caused historically and currently in terms of carbon emissions has to be addressed. So you have to change your footprint and maintain, you know, reasonable social and economic aspects. So the trajectory of how we get to sustainability is going to be very different depending on where you are. So I hope that gives a kind of a feel for how sustainability and the SDGs relate.
Yeah, thank you. Thank you.
Anybody else would like to address that question? Well, let's move on then. There's also a string of questions going on in the chat, by the way. So there are very interesting questions coming up. Of course, this is all getting recorded, so all of these sessions would be available to everybody. But let me move on. I know that there are a number of questions have come in. So Jim, why don't we go with your question next?
Okay, this Jim. Hello, can you hear me?
Yes, we can hear you. Go ahead.
Okay. Yeah, I guess my biggest question I've had is, you know, a lot of BIM and the technology that people have been writing on for the last several years. I see artificial intelligence being the next major topic and research point. I guess my question is, how do you balance the fact that that's going to be a powerful tool with the fact that it's going to require such a huge amount of new electricity being built in the world to power that? How do you balance that from a sustainability standpoint?
If I may,
Go ahead, please.
every innovation when it starts, it starts and it proves the principle, but still you need to work on it. And I think the use of digital tools, the use of AI, and as you said, the amount and energy it consumes and how it affects the environment. I think it should be something that we focus on as we develop the next generation. In everything, they're making decisions is a complex process, and you don't have you tend to have pros and cons for every aspect, and you need to have a long-term view. But I agree with you. We need to realize where the current innovation is working, where it's failing, and how we can develop it even further.
Thank you. Professor Beats?
Yeah, so on that topic, thank you, Jim, for this excellent question. I think one of the most maddening things at the moment is that the big vendors of transformer models, they're considering building nuclear power plants just to operate their training grounds, right? For the which is really, really crazy. On the other hand, I think that we're not going to see further acceleration on that from a very technical point of view. The visible internet, or the visible the visible parts of the web that has been crawled so this limit has been reached. Everything that is available has been through the so-called big crawl, so harvesting each and every type of information that is available and then training your models on them. That seems to have peaked already. There's not enough information, new information, to be digested by transformer models. So the next thing that you see, and this is what led to the first kind of mini crash well, on the downward slope of the hype cycle, is when you see that the large language models now are getting compressed by harvesting language models on their own. So the DeepSeek example from 2 weeks ago or 3 weeks ago, earlier this year, let's say, there is exactly one of those developments where further compressing and miniaturizing
He did it quick.
things also means less energy. So that might be one of the ways out.
Thank you, Jim, for that question. I know that number of questions have come in. So Zahir, let's go with your question next. Oh,
So my question, hello, am I audible?
yes, go ahead.
Yeah, so my question was related to cost and scalability and in what could be the barriers to industry-wide adoption. But I think my queries have been addressed by Professor Dulemi's presentation.
Okay, excellent.
Looking at, yeah.
Okay, yeah, thank you. Professor Widener, you had a question coming up.
Yes, thank you for all the great presentations. One theme that I think I'm hearing is that adoption is difficult. We have users who are maybe not using facilities efficiently. We have owners who don't realize where the expertise lies. We have owners that are concerned about the high cost of trying a new technology. What ways can be used to encourage people to experiment or to adopt the technologies faster?
Go ahead, Jacob.
Okay, I don't know whether this was addressed at a particular person, but I think one of the ways is to really lower the boundary of the entry threshold and the entry level. So opening up technologies has always been an accelerator. The internet and most of the technologies associated to that wouldn't be possible. They're running for 89%. They're running on open source technology. And making it available for example, to students around the world, to me is one of the keys to next to education, obviously, to incentivize people to just give it a go. If you go to places like, I don't know, let's take AI and the generator transformer models. If you go to places like huggingface.com or .org, you have 150,000 GPT-like models that you can download for free and load it onto your phone, on a low spec phone, to start getting you to start doing things disconnected from commercial services. Well, that's one of those examples where really I at least incentivize students, really, let's develop a cause, and I'll give you the basic lay of the land, and then you go and experiment. And that's kind of the generation I hope to educate at a university level. So opening technologies up instead of hiding them immediately behind business model, immediately behind the big commercial vendors that buy things to the left and to the right, and then hide it behind paywalls that are not accessible to most parts of the world. Certainly seems to be one of the ways out.
Yes, Jeremy, go ahead, please.
We did some quite interesting research to look at kind of how people change. What are the things that encourage people to do things differently? If you're looking at sustainability, there's a whole set of issues around that. And the kind of key things are, firstly, awareness, just knowing the impacts of your your life and your patterns. So knowledge, very important. Awareness, very important. Your peers, what do your peers think? And what's your relationship with the people around you? If they encourage your behavior, great, that makes a big difference. The same thing with your family, your parents, your children, etc. All of that makes a big difference. Very important, particularly in South Africa, is cost. If something is cheaper, even by a small amount, people will go into it, or if it's not much more expensive, but has a much more beneficial impact, cost, does make a difference. And then the last thing is ease. I mean, if you look at things like recycling and a lot of changes in behavior, if you make it easier to live a particular way or work in a particular way, so environmental design, also makes a big difference. And it's one of these things where if you're going to encourage people to travel less or not use a car, you need a trade-off that actually is better. And I think 15-minute cities are very good examples. Is you don't need to have your Mediterranean holidays quite so much, and you don't need, to drive your car if the quality of environment around you is so much better, is so enjoyable, you have such good quality of life. And so it's this trade-off. And I think that's the really important role of designers, is to show that sustainable solutions, sustainable environments actually are far more attractive. So why would you want to have a worse quality environment that's less energy efficient, etc.? So that's really, I think, the kind of 4 or 5 things that we found in our research. Thanks.
Yes, Mohammed, go ahead, please.
Very briefly, I think what the industry wants is to see commitment to that direction before they invest in developing skills, in developing new technology. They want to make sure that there will be commitment to that path. We have now clients publishing their pipeline projects. So not the projects they want today, but the project that they're going to ask for next 5 years. And they set their priorities. That provides the motivation to the industry to develop the innovation and adopt it, because they can see they can recover their costs and they can make a profit.
Thank you all. I think we can squeeze in 2 quick questions. I know, Jorge, you had a couple of questions, so let's go with your question, and then I'll put in my last question in the end. Jorge, go ahead, please.
Thank you, Professor. Yeah, I believe my question was more general about how we can probably motivate more. How is the lack of knowledge of construction experts regarding technology? How may affect the use of these technologies in the future, and how long will it take to make probably more common to see that they're using technologies in the job site?
Anybody wants to tackle that question? It's difficult to say how the diffusion of knowledge spreads, and there's a wide variety of variance from one location in the world to another location in the world. I think it depends on availability, usage, access, diffusion, a lot of those issues in my opinion. But let me open it to the panel. Jeremy, go ahead.
I can say maybe kind of fairly quickly. This is the role of university education, is that you can if you incorporate sufficient technology education, people become used to it, and they'll, it just becomes a habit. So I think that's very important. CPD is very important, exposing built environment professions to technology and getting them to use it. I think the last thing is something that can be driven by procurement. So procurement can say, I mean, BIM models are a very good example, is that you have to be compliant, or you have to understand how to use it and have certification. And you will find very quickly firms become compliant and they fully understand the technology because it's their next project. So I think there's probably a mixture of 3 or 4 things that you can do to make sure there's good access, and costs again, and the barriers of getting into the technology also make a difference.
Thank you so much.
Unfortunately, we are running out of time. So let me try to summarize and throw in my last question. So there was a need, a lot of good points came up, and I'm sure I have a whole set of questions in front of me, and I'm sure there'll be many more questions to address. But you all brought out very important issues about, Jeremy, you mentioned need for policies for SDGs, that needs to be adopted and developed by not only countries, but also companies for their own use, and how they want to implement sustainability through their practices and in their environment. Knowledge and awareness, that was brought up as an important issue, that unless there is knowledge and awareness of technology and knowledge about the technology, that diffusion is likely to be very less prevalent. Also, ease of entry point for technology, that was brought up earlier in the conversation, that how can we make sure that the technology that is available has a easy entry point, is cost effective, is perhaps open source, so is readily available and can be developed further. So I think these were some of the important points that I was able to quickly capture. But the number of questions have come in with respect to the use of AI, ChatGPT, DeepSeek. There was a little bit of discussion on that. So my question to all of you, and let's say 30 seconds each in closing, would be that ChatGPT and DeepSeek, they're based on data and the richness of the data. So when it initially starts, the developers might put in a good database, but as it gets used, then it starts diluting, if that is the right word, in terms of not what knowledge the users are feeding into the database, that then becomes part of the collective. And my fear is that if it is not maintained, the quality of data being put in is not maintained, we might end up with garbage in, garbage out, or at least a low normal that everybody will take as a given, which is quite frightful. So that's my statement, but let me open it to each one of you for 30 seconds to see your comments on that. Jeremy, let's start with you.
Okay, thank you. I wouldn't start with AI as a starting point. I think it's very important, especially for students and researchers, to understand the principles and the basics and the science. And if you don't do that and you use AI straight away, you can be given a solution that you think, this is great, it works. And because it looks slick, because it looks well thought through, you adopt it, and then there's all sorts of unintended consequences. So very important, build your knowledge base, really understand the science, understand the data. And once you have that, find a particular solution, a particular problem, and frame your questions very tightly around that. And then AI can be incredibly effective. But the big thing is that you have sufficient capacity, you have sufficient knowledge to be able to understand and assess the results in a way that enables you to value whether it actually works or not. So that's my quick answer.
Jacob, let's go to you next.
another angle is research data management. So, and this is for all the chapters in CIB and for all the working groups, making it mandatory to supply reproducible test cases, well-curated research data with everything that we publish, is really crucial to make sure that we're working on that we're progressing, because in other fields in computer science, it would be unimaginable to publish a paper and not have a data set along with it, so that you can really test it out and see whether you're performing better or worse. And in the build environment, particularly, at least in my research bubble, we're still quite far behind of making this a mandatory part of the culture. If you're publishing something, then please provide the research data, and we can we can stop doing anything AI, anything machine learning based, anything that goes beyond the big crawl, if we're not starting to provide and curate and carefully prune our own domain specific data sets. 45 seconds.
Thank you, Jacob. Shen, let's go over to you.
Yeah, I think in the future, definitely. So AI will be used to control for the building systems. So, but if we say of course, we need to control the quality of the data collected to enhance the database. But it is unavoidable. We need new data, because so people's behavior, people's preferences are different. So there's no conventional control algorithm can be used to fulfill all of the people's requirements. So we need the new data to correct the existing control theory or control strategy, and then to adapt to the what we call the tailored control strategy. So yeah, that's my opinion. Yeah, so it's unavoidable, but the control of the data access is very important.
Thank you, Shen. Mohammed, let's wrap it up with you.
Yeah, I think we need smart people to be able to use smart devices and smart solutions. I think that's very important. They need to understand. We need to understand the roots of this output, and therefore be able to use them to help us make better decisions, rather than having this illusion that it is the smart way of making decision itself.
Thank you all very much. Those were great insights. As I said, I had a list of questions that had come in, and I'm sure as if you were to continue discussing, we can go on for another couple of hours for sure. But I want to thank all of you for taking time. I know you're all coming from different parts of the world, different time zones. So it is really fortunate for us to have you on the panel, and for the rich point of view that you have presented in the follow-up discussion. So I want to thank all the audience and our panelists. Let's give them a big round of applause. You can open your mics and give our panelists a round of applause, please. Excellent.
Thanks, guys.
Well,
That's very enjoyable.
Thank you. Thank you.
For me, it's goodbye into the weekend, or for us over here in Europe. This was the very
yes,
last.
indeed. Yes.
For the working week.
Everybody have a great weekend.
Yeah,
And,
enjoy a good weekend.
Okay.
Bye-bye.
Cheers. Cheers,
Bye-bye.
everyone.
And stay
Bye-bye.
tuned for next week.
Yeah.
Thank you all.